In this lesson, we're investigating spontaneous reactions and Table J. Our lesson objectives: we're going to use Table J to determine if a species is oxidized or reduced and determine if a reaction will occur spontaneously. So let's open up our reference table to Table J, our activity series. And so on the left-hand side, we have the metals. And at the top, it says most active, or we could say most reactive. And so these are our most active metals that we have, and as we work our way down, they become less active. The most active metals are easily oxidized. What does oxidation mean? Remember, it means to lose electrons. So the higher up you are, the more reactive you are, the more easily you give away or lose electrons. As we work our way towards the bottom, we get to our less active metals. These are not so easily oxidized, so they don't lose electrons easily. So it's hard for them to lose these electrons. So basically it means that these things are not very reactive. If you look at the elements, we have copper, silver, and gold. These are our precious metals, and that would make sense that we wouldn't want these things to be very reactive with other substances. If you think about your house, we use copper pipes, and we don't want those things easily oxidized because with a lot of material that's going through there, a lot of different substances, and we don't want them reacting with them. On the right-hand side, we have our nonmetals. It's going to function roughly the same way as the other side, where the most active is at the top and the least active at the bottom. But remember, nonmetals like to gain electrons. And so the more reactive nonmetals up top are more easily reduced. Remember, reduction means a gain of electrons. So the higher up you are, the more easily that you'll gain electrons. And then the lower down you go, the less active you are, and you're not so easily reduced, meaning it's hard for you to gain electrons. Okay, let's look at an example. It says compare nickel and aluminum. So here is aluminum, and here is nickel. And if we're comparing these two, we want to figure out which one would have a greater chance of being oxidized and which one then would be reduced. So if I have these two elements in a reaction, which one's going to lose electrons and which one's going to gain? So we said the most active, the more reactive, are going to be higher up, and they're more easily oxidized. And so since aluminum is higher up on Table J, it's more easily oxidized, it's going to lose its electrons. And therefore nickel, since it's lower down, it's not so easily oxidized, and therefore it's going to actually get reduced. It's going to gain those electrons from aluminum. So aluminum is oxidized because it's higher up on Table J, and then nickel is reduced because it's lower down on Table J. So let's check your understanding. Can you use Table J to determine if a species is oxidized or reduced? So now, when are reactions spontaneous? Spontaneous means the reaction is going to occur without the addition of any extra energy to the system. And so if we look at a reaction here, if the uncombined element on the reactant side is more active, meaning higher up on Table J, then the element in the compound on this reactant side, on the left side, then the reaction is said to be spontaneous. So essentially, if this is more reactive than this metal, it will swap it out. It will replace it. So we find it on the reference table on Table J. We find zinc. We're going to find Pb, which is lead. And we see that zinc is higher up. So zinc is more reactive, and therefore it's going to replace Pb in the reaction, and this would be a spontaneous reaction. If it's not higher up on Table J, then the reaction is said to be non-spontaneous, and it will require the addition of energy. So without any extra energy, no reaction would take place. And so in this example here, if we look up zinc, is here, and then look up aluminum, is here, we see that this uncombined element, the zinc, is going to be lower than aluminum. It's not more reactive, and therefore it's not going to replace aluminum. And this would not be a spontaneous reaction, so without adding any extra energy, nothing would happen. So let's see an example. Would this reaction occur spontaneously? So we're going to first locate the uncombined element, lithium, and we find it way up here. It's our most active metal. We look for magnesium. Magnesium is going to be here, Magnesium is lower, so lithium is higher up on table J, it's more reactive, and therefore this reaction would occur spontaneously. Another way you might see this is they may remove the spectator ions. These are the ions not changing oxidation number. And so you may see it written like this, where they're just writing the charge of the ion in the compound. And the same thing here. So lithium plus 1 and magnesium plus 2. So if you see it that way, it's still going to function the same way. The uncombined element, that's the one that's going to have the oxidation number of 0. That one is the one we're looking for. If that one is higher up on table J, it's going to be spontaneous. And if it's lower down on table J, then it's non-spontaneous. So let's check your understanding. Can you determine if a reaction will occur spontaneously? At this point, you should be able to use table J to determine if a species is oxidized or reduced and determine if a reaction will occur spontaneously.